so back to the quadratic stroke, right? So the first thing that we're going to do, we're going to look at a quadratic graph, and we're going to start off with talking about the ordered pairs which belong to a quadratic function. But what you'll notice with this graph, right, you already have a graph, and you'll notice specific points, they have like little circles to mark off those points. So what I actually want to do is see if you all are able to get the values that you're supposed to plot to create this quadratic graph, because we actually have the graph, so you can always just check back the values once you can read them off properly. So here's what you're going to do for me, right? So let me just add a page, right? So the quadratic function that we're dealing with is x squared minus 3x minus 3. This is our function, right? I just use an y because the y coordinates would come out of this quadratic. Now, how many people remember how to do a table of values? Just raise your hand quickly. How many people remember to do the table of values for any function? Raise your hand. All right, I see 2 hands go up. All right, so then it's a good thing we're going to go over this. Okay, so when I say table of values, right, I'm talking about we have values of x and values of y. So anybody here can remember what we call the values of x that are specific to a function? Anybody? Okay, so for every function, there's a specific set of x values that would correspond to a set of y values. What do we call the x values specific to the function? What do we call the set of x values? Alright, just give me a minute. I just joined a table. That's why I really take it as one now. So giving Ali a minute to think about it, right? What do we call the x values that are specific to a function? Anybody? Anybody had enough time to think? There you go. It starts with a D and it is domain. So when we talk about x values specific to a function, we're talking about the domain, right? And anybody remembers the, well, I'll put in notation, right? Anybody remember seeing things like this when we were dealing with functions last year? There we go. So this is our domain, right? We're going to use the domain for our function to help us with obtaining those ordered pairs so that we could plot the graph. So the first thing that we're going to do, we needed to know the values of the domain. So just to verify that the domain is what I have written here, right? So just look at it again. The domain I have written is -1 to 4. Look at the graph. Tell me if you all agree with that domain, or should I change the domain? All right, so I have one person who agrees with it. Anybody wants to tell me what they think? Do you agree that the domain of this specific function is from -1 to 4, or should I change it? All right, so we only had one person saying they agree. How do we check for the domain of the function? One of the things that we need to look at carefully, right? So it's easy to get tied up, and I just was looking for two values quick to write a domain. But when I looked at it, I didn't pay attention to the top here to see if it had 2 points, right? So I just looked at it and I saw -1 and 4, and those are the two easiest things for me to write down. But if I look even closer, I realize there's a point at the top here for each side of the graph. So that tells me that my domain for f of x is not between -1 and 4. My domain is actually from -2 all the way to +5. You'll see what I'm talking about over here. My domain, look at it. I have a point plotted where x is -2, and I also have a point plotted where x is equal to 5. You'll see that? So that's right. So that means my domain, I need to adjust the domain that I have written here, right? So the actual domain for f of x is from -2 to +5, right? So now that we have the correct domain, we're going to just fill in our table, right? We're going from -2 all the way to +5. Need an Excel. Right. So anybody wants to just tell me what will they do to get the corresponding values of y? Anybody? All right, just get the ordered pairs for the points. Anybody wants to tell me what do you do to get the y values that correspond to the values of x for this function? There we go. So you'll remember doing questions where you had to take the function, whatever the function was, take the values of x from the table and plug it into the function. So as you said, it's a substitution. So just to kind of start you all off a little bit, you'll remember doing something like this. Anybody remembers doing something like that? There we go. So we'll start you all off with the first one. And then from there, you can work on the rest. So just remember, when we deal with these things, right, directed numbers always gives people problems, regardless of what they're working on. So pay attention to the signs. Remind yourself if you're squaring a number, what should happen to this sign if you're dealing with a negative number. Remind yourself as well to check the signs when you're doing products. So over here, -2 squared will give us a +4, right? Because -2 by -2 is a +4. Next, we have -3 by -2. So the product of two negatives will give us a +3. 2's are 6. And then finally, our constant -3. Just bring that forward. Now 4 plus 6 is 10, and 10 minus 3 is going to give us the answer for y. So y is equal to 7. Okay? So the answer that we're going to put in the table is that when x is -2, y is equal to 7. So I'm just going to go back to the graph and we'll see if that is in fact the point that they have plotted here. So at this point, x is -2, and then I read across the y-axis, y is 7. So we got the correct points, all right? So that's what I was saying. When you are completing this table, you will be able to double check to see whether or not you have the correct points, okay? So let's see, we have 6 more points to do. So I'll give you all 6 minutes to work on it, right? And could I get some people to just, volunteer their answers so we could just validate using the graph and make sure that you're all on the right track. So 6 minutes, you'll think you can handle doing the table of values? See? No? Alright. So go ahead, work on it. There's another way that we could also do the table of values, but how to put it? Sometimes it could be a little bit confusing, and I just don't want to do too much in terms of getting table of values right now. We can look at it probably Tuesday when we back out. So for now, like I would say, I would let you all do the table this way. And if people still having issues with getting table of values, we'll do it the other way fixed it. All right? Okay, so I will just kind of add in a slide. I'll do -2. So -1 now. So we'll see how many people get all the answers correct. Alright, so anybody worked out what x is equal to minus? When x is equal to -1, what is the y value that corresponds to that? So remember, you could, yeah? To the back? Okay. Anybody worked out the value for y when x is equal to -1? Let's see. So we square -1 and we get +1. -3 by -1 is a +3. Minus a 3. So right here we can see, well, +3 and -3, we know we'll get 0 there and you'll get 1. So excellent. First value that we had to work out, the answer for y is 1. And again, we can go back to the graph and we'll see for ourselves. So where x is -1, y is +1. So very good. All right. Next one, when y is equal to 0. Anybody here could tell me what happens when y is equal to 0 for any graph? When y is equal to 0. You could think about that while you're working on the value, right? So what happens to the graph when y is equal, not y, when x is equal to 0, sorry. What happens to the graph when x is equal to 0? There we go. That's correct. So whenever x is equal to 0, that's when our graph will cut the y-axis. There's a term that we use to refer to that. Hopefully somebody will remember it just now. But yes, literally the graph itself, the point that we'll plot will be on the y-axis. Lovely. That's it. It's the y-intercept. All right. So anytime we see x is equal to 0 and we have any equation at all, we know that we substitute x as 0. So the only thing that should remain in this case would be the constant, right? So anybody wants to tell me what they got when x is equal to 0, what is y? -3. Lovely. So look at that, we have some people getting the same answer. So we can check it back now. When x is equal to 0, x is equal to 0, y is equal to -3, and there you go. Look, and it is on the graph itself, on the y-axis, like she was saying, like I didn't mention earlier, right? We are going to see that the graph will cut the y-axis when x is equal to 0. So we have 3 values so far, and we know that all the values are correct because we're seeing them on the graph, right? So we're going again. When x is equal to 1, what will we get? Let's see, will we get negative 5? When x is equal to 2, we get any negative 5? Yeah, you skip 1. Alright. So let's just double check. Is the answer what she says it is? Let's see. 1 minus 3 minus 3. So we'll get 1 minus 6, which would give us minus 5. Okay? Right? So again, like I was pointing out, the one thing that this activity will do, it will kind of give you a little bit of confidence boost in your ability to work out the values for the table, because you can just check back and see, did you get the correct value here, right? So we fill in the next value for y, which is minus 5. Now we need to do x is equal to 2. And I believe Genesis said she had gotten minus 5 as well for this, because she had worked out for 2 instead. So let's see if she's correct. So we'll get y is equal to 4 minus 6 minus 3. Yep, you're gonna get negative 5. Right? And one of the things that we have to remember about a quadratic is one of those functions that mirrors itself after a point. So what we notice here with those two values of x having the same value of y is that you're going to have a certain mirroring effect from here now. Alright? And you can see it, that the value is correct. When x is 2, y is equal to minus 5. So we just have 3 more values to work out. Right? So, like I said, the purpose is just to kind of give people that little boost with being able to work out the values for the table. And especially where working it out is concerned, some people with making mistakes with their powers, with their signs. So at the end of the sessions this week, hopefully we won't see some of the mistakes that we would have seen prior to this. Okay, so anybody wants to tell me what they got for the y value when x is equal to 3? Let's see. Alright, so we have another negative 3. So 3 squared will give us 9. 3 by 3 is 9, so 9 minus 9 so far. Minus another 3. So yes, that's correct. You'll get y to be minus 3. And we can see that again on the graph, right? Right here. When x is 3, y is minus 3 as well. And notice, like I said, that mirroring effect that is happening with the quadratic curve right now. So we have 2 more values to go. So when x is equal to 4, what is y? So y is equal to 4 squared minus 3 times 4. So anybody wants to tell me their value? Let's, alright, so we have a 1. 16 minus 12 minus 3. Excellent. The answer is 1. Alright. And we see that here on the graph as well. So let's write that in. So when x is 4, y is 1. Listen to it. The last value will end up being 7. Simply because in this case, what we ended up having is a quadratic that gives a nice, perfect little mirror. Sometimes when we deal with quadratics, we might not get, values to mirror each other in that way. So that's why we always try to work out all the values when we have to get the ordered pairs to plot. So working out the final one, let's just make sure that we get the correct thing, right? So 5 squared minus 3 by 5 minus 3. And yes, you'll get 7, because 25 take away 15 is 10, and 10 take away 3, 7. Alright, so there we go. We get all the values. Right? We can see all the points that they have plotted here correspond to the table of values, right? So, like I was saying earlier, one of the objectives is to make sure that we can get the ordered pairs for the quadratic. You'll remember how to get your ordered pairs from your table. Anybody wants to just suggest an ordered pair that we will plot for this quadratic? -2 and 7, yeah, very good. And you could also, well, just for everybody's benefit, -2, 7 would be 1 point, -1, 1, 0, -3. So just remember, pair an x value with a y value. So the two values in any one row would give us one coordinate, and that's what we plot. So based on what we just did, does everybody feel 100% comfortable with the idea of obtaining the ordered pairs for a quadratic function? All right, so we're good to go here.